Testing antacids. Introduction. What is heartburn and what causes it? Heartburn is a reflux acid being forced into your esophagus. Heartburn is caused when acid refluxes the food, acids, and enzymes from your stomach back into your esophagus. When the acid refluxes, it presses on your esophagus, causing pain and inflammation. What is an antacid? Antacids are a form of medicine to help counter the effects of acid reflux in the stomach. People often use this medication when they have heartburn. How do antacids work? Antacids are a basic solution, and the broken down food and enzymes in your stomach are acidic. When the two combine, they cause a reaction in the stomach, neutralizing the stomach acids. This process is called neutralization, as it makes the stomach acids less corrosive, relieving heartburn. Do all antacids have the same chemical makeup? Generally, commercial antacids have the same aluminium and magnesium hydroxide. However, some antacids have sodium carbonate, calcium carbonate, and acylic and sulfates in them. This means that all antacids are fairly similar with some slight variations. What am I testing? Aim: to determine which brand of antacid is most effective at treating heartburn. Hypothesis: all antacids will be able to neutralize different amounts of stomach acids. However, the acid with the highest pH level will be the most effective at neutralizing stomach acid. I feel this would be ready because according to my research, it has the strongest chemical makeup. Results. What have I discovered? By conducting this experiment, I discovered that different brands of antacid, Rennie, Gaviscon, Mylanta, have different pH levels. Rennie 8.2, Gaviscon 7.2, Mylanta 7.4, and therefore making them more effective than others. I was also able to show this in the experiment by combining the water and different brands of antacids and hydraulic acid. This means when a base and acid combine, they go through the process of neutralization, making the pH of the solution 7. By doing this experiment, I also learned a lot about how antacids are a form of medicine to help counter the effects of acid reflux in the stomach, how they work by causing a reaction in the stomach, neutralizing the stomach acids, as well as how heartburn is acid reflux being forced into the esophagus, and how it is caused when the acid reflux is pressed on your esophagus, causing pain and inflammation. By conducting this experiment, I was able to find that Rennie was the most effective antacid. The table supports this as it shows that Rennie required the most hydrochloric acid to neutralize the solution, and the graph supports this as it shows the pH levels of the basic solution before the hydrochloric acid is added, and how much hydrochloric acid is broken down by each antacid. Recommendations for future attempts. Although the overall experiment was a success, there was only one major problem. This problem was how the crushed up antacid stuck to the glass rod and the edge of the beaker as I was stirring the mixture. This most likely changed the results, as some of the powder stayed on the glass rod and got removed from the mixture, or it just stayed on the edge of the beaker, meaning it didn't get tested. I think this can't be avoided no matter who did the experiment, making the results with this experiment different every time. If I were to alter the experiment, it would be to put the antacid tablets in the mixture without crushing them. Even though they would dissolve slower, I feel they would dissolve better, this is how the tablet works when it is in your stomach. Conclusion. I was able to achieve my aim and determine that Rennie was the most effective brand of antacid that I tested. My hypothesis was that all antacids will be able to neutralize different amounts of stomach acid. However, the acid with the highest pH level would be the most effective at neutralizing stomach acid. This was proven to be true, as shown in the table and graph in my results. I found that the antacid with the highest pH level was the most effective at neutralizing stomach acid. Thank you for listening.